Hi there! Now we will have a code practice into detecting of data drift. I believe this is very interesting because we are going to explore different methods and see how we can even create a custom drift detection method and use it in Evidently drift detection report. So let's dive in. I already prepared a couple of instructions for you so that you do not need to watch me doing it again. It's very similar to what you just saw previously when we tried to create some reports and test suites for data quality and model quality with help of Evidently. So I'm going to use quite a lot of similar libraries like Pandas, NumPy, scikit-learn, and now we are going to play around with some drift detection methods, so we will need to use some statistical tests. This is why I also import Mann-Whitney test from SciPy stats. So if you do not have SciPy, take your time to install it. You can do it with help of pip install as well. Here is also a couple of new commands you can see here. I imported warnings. This is a library which helps you to get rid of some unnecessary warnings or some other messages. So I filter out warnings by setting the ignore option to the filter warnings and simple filter. So that's because I don't really like to always update my libraries, and sometimes I have quite a lot of future warnings. They're actually very helpful, but I just decided to do that. Now let me quickly show you what we can do for data drift detection. So in Evidently we have quite a lot of different drift detection methods already implemented so that you can just use them. And we have quite a lot of ways how you can specify how to process your data set and how to detect drift for all particular features. So in this video I'm not going to show you how you can work with unstructured data like text and embeddings. We are going to discuss this in the next module, but now we are going to focus on the tabular data. So for tabular data, you can use the default stat tests because Evidently have the algorithm which automatically select the right statistical test for each of your tabular column, depending on the column type, depending on the size of your data and the amount of different categories in case of categorical data. So you can actually do not specify anything and already come up with the good choice for statistical tests and other drift detection methods. If you have an idea of what drift detection method you want to use for your particular columns, you can perfectly specify it with help of the following parameters. So there are parameters like all features stat test, num features stat test, cut features stat test, and per feature stat test. And with help of those parameters, you can specify which drift detection method should be applied to all features, all numerical features, all categorical features, or per feature. So yeah, probably we're gonna need to rename stat test to drift detection methods because now we have not only stat tests but also quite a lot of distance-based options to detect drift. So that's how you can specify what drift detection methods to run over your tabular data. What are available methods? So we do have a lot. It's like Kolmogorov, Smirnov, zstat, chi-square, Jensen-Shannon, Kullback-Leibniz, PSI, and etc. etc. You have a full list here for your convenience so that you can just check what you like most, and you also can implement a custom drift detection method, which not necessarily should be a statistical test, but can be, of course. And well, actually, if you can create any method which takes two data samples and returns like numerical value with the binary decision whether drift is detected or not, it can work as the drift detection method for Evidently. So that's basically it. And also I'm going to use adult dataset, which we already used before, because I already created a way how we can introduce the specific shift into the dataset. So it will be quite interesting to see the drift detection report on top of this dataset. So let's dive into it. And I would start from dataset drift detection method because quite often, if you do have a lot of columns in your dataset, you don't really want to see the results of drift detection for each individual column. You might want to, but just imagine yourself having 2,000 of columns, and all those columns are features which are not really strong, so we build the model on top of a lot of weak features. In this case, you would rather see the share of drifted features, but not the drift detection results for all individual feature, right? And Evidently can do it for you. So let's start. I will add some title here. Let it be drift detection report, and now let's calculate the number and share of drifted features for the whole dataset. So here we are. What I just did, I created the data drift report. This is the evidently report, and I specified some metrics. In our case, I just specified dataset drift metric so that we can see the number of drifted features, share of drifted features, and understand the situation for the whole dataset. So let me run it, and here it is. So we can see that there is the dataset drift report, and we can see that dataset drift is not detected because we analyzed 15 columns. Drift was detected only for 5 columns, so share of drifted columns is equal to like 33%, but the threshold for dataset drift detection was set to 50%, right? So this is why dataset drift was not detected. And of course, you can customize all the thresholds so that you can detect drift on any level you want. So that was dataset drift detection method. Sometimes we might have the opposite situation where we do not build our model on top of like tons of weak features, but vice versa, we have quite a limited amount of very strong features like key performers, and we build our model on top of such features. In this case, we might explore not only share of drifted features, but also want to see the drift for particular features, so that like we can get an alert if like a lot of features drifted with help of share of drifted features, but also we could get an alert for individual features drift in case those features are very important. For doing that, let us build a report for column drift detection. So let me copy the initial instructions, but instead of dataset drift metric, I would go for column drift. So here we are. Now I created the same report, but instead of dataset drift, I use column drift metric. And well, I have two metrics here, both calculate drift for education num, but for my first metric, I will use default drift detection method, and for the second metric, I would use drift detection PSI, population stability index, so that you can compare the different ways of drift calculation, because I believe you remember that drift detection is just a heuristics. There are many different ways how you can calculate data drift. So let's compare two options on top of a single column. And here is our report. So you can see that by default, evidently decided to calculate Westerstein norm distance for this education num, and drift is detected, right? So we can see that here is the drift value out there, and here is the distribution. So that's, well, that's education num. It's not so convenient to analyze it because that's numerical values of education, but we can assume that, if I'm not mistaken, for this data set, the higher value we have, the higher degree of education there is, but it's just my hypothesis. It can be not the case here, so it's just assumption. And, well, we can see that the data are quite different. That's because we created our data sets this way. And the second is, again, drift for education num column, but now with the population stability index. Why so? Because we just specified here. And the drift is detected again, but the values are quite different. So drift score is equal to 15 because that's the other drift detection method. So that's how we can calculate drift for individual columns. Together with that, we have a very nice metric which is called drift detection table. So let me show you how we can run it. Now, instead of dataset drift metric, I'm going to use data drift table. So I rely on after completion here, data drift table. And, well, you saw that there are quite a lot of different options how we can specify drift methods for numerical, categorical columns, and etc. So let me start from the default choice of drift detection methods. Here we are. So that's the data drift summary, and we can see that the same percentage of features drifted as we saw before, and we have a pretty nice table, right? So we can open up each individual feature and see the distribution here. For example, for categorical feature education, we can see that, well, there is like no intersection in terms of drift, right? Because that's how we created the data set. No intersection in terms of the values for education, right? Because we split it actually data sets by the education. And that's why, of course, drift is detected here. And very similar visualizations are available for each individual column. So we can see it for education now here. We can see it for age. And then we can explore all individual columns, which is very useful, especially if you are doing some debugging and want to understand the reason for drift, maybe share it with the domain experts, and all together see what's going on and how you're going to fix the issues with the data. So I really like this table. And now let's see how we can specify some methods to detect drift, for example, based on the types of our features. So I'm going to specify some stat tests for numerical and categorical features. Let me go for numerical features with PSI. I like this method. And for categorical features with, for example, let me check what we have. Chi-square or Jensen-Shannon. Let me go for Jensen-Shannon. So here we are, and let's run it. Now you can see that for all numerical features like education num, age, we have PSI. Capital gain, what else do we have? Quite a lot of numerical features, right? But for all categorical features, we have just Jensen-Shannon distance because we specified it like this right here. So it's very, very flexible. And finally, let me show you how you can specify the drift on the column level. For doing that, I would need to create a dictionary where for each column I will have some specified drift detection method. So let me implement that. Well, they have quite a lot of features, so don't think that I just randomly assign the right drift detection method. I still have in mind the types of each column, so let me continue. Hope that's correct. So now let's pass our dictionary to our report. So now we need to specify per feature stat test. And let's see if we did it correctly. Of course not. Okay, let me copy a name for Wasserstein. I hope it was the only issue. Yeah. Now we can go and check whether we assigned all the drift detection methods correctly. But I guess so, because I do see the Kullback-Leibner, Wasserstein, Jensen-Shannon, Anderson-Darling, and etc., etc. So exactly as we specified for our features, and well, the drift detection level just increased because of our choice of statistical tests, right? And finally, here is one more thing I wanted to demonstrate to you now, and this is how we can actually specify the customly designed drift detection method. And for doing that, we will need to implement this drift detection method, and I'm going to just create an cover object on top of SciPy state test and show you how you can pass it to Evidently, because that's really cool how you can come up with your customly designed method and use it for drift detection. I will start from the function implementation. It will be the function which calculates Mann-Whitney test for 2 samples. So yeah, basically we need to pass to our function 2 samples, reference data and current data, and then feature type, which is allowed to this drift detection method, and threshold to detect drift. So that's my function. Basically what it does is calculate Mann-Whitney U test for 2 data samples, reference data and current data, and I return drift score, which is p-value in this case, and the check of my drift detection test, which is compare the drift score with the threshold. In this case I just compare the p-value with the threshold, and if the p-value is less than the threshold I return true, drift is detected. So now let me create the object which I can pass to the Evidently data drift table metric, for example, and as well for column drift and other metrics which related to drift. So let me implement that. So this is the template for creating the stat test object, which we can pass then to data drift detection related metrics. And now we need to fill this object. So we need to come up with the name, with display name. It is the name which will be displayed in, for example, this drift table. Then we need to specify a function and the list of feature types to what we can apply this drift detection method. So let me come up with some nice name, which is Mann-Whitney test, right? So our function is the function we just implemented before. And we can apply this test for numerical columns. That's it. Now let's try to use it in our data drift table. We know that we can use this test for numerical columns, so let us specify it. Num stat test and our Mann-Whitney stat test. Well, looks correct. Let's try to run it. And here we are. So it started from the categorical features with Jensen-Shannon distance, and then our Mann-Whitney test. So it's just a function that you implemented yourself, as I just did, and that's the output. So that's how you can specify your customly implemented function for drift detection. Basically, it's all I wanted to share with you regarding data drift detection with help of Evidently library. I do hope you guys enjoy it because, well, it's very useful, especially if you do not have the ground truth right there in place and work with the problem statement where you have delayed feedback. The data drift and other data quality metrics can be very useful for early monitoring. So feel free to play around with the tool and leave us some feedback.